All right, this is going to be the first video for Notes 46, and the first thing we're going to talk about is linear inequalities and linear equations. And I'm actually going to start with question number 2 here, all right? Linear equations. So this is a equation. We've got x's on both sides. We've got to do some distributive. Let's solve this thing. So we're going to distribute and distribute. So 3x minus 18 equals 2. I need to distribute some more. Minus 5x. Distribute some more. Minus 10. I want to clean up some like terms here. So left side, I've got 3x minus 18. Those cannot be combined. On the right side, I've got 2 here minus 10. So let's go with negative 5x and then a minus 8. All right, I have now everything combined on both sides. Let's go ahead and start swapping stuff around. Not a huge fan of having both x's, right, on two different sides of the equal sign. So let's maybe add a 5x to both sides. So plus 5x, that's gone. That's going to get me 8x minus 18 equals negative 8. Now that I've got the x trapped on one side, let's go ahead and get rid of the constant. So add 18 to both sides. So 8x is equal to, what would that be, 10? Sure, that sounds good. And last but not least, let's go ahead and divide both sides by 8. And we're going to get x is equal to, now, 10 over 8 does not divide perfectly. You're going to get some kind of a weird decimal. I'm not a huge fan of the decimal. And so what I'm going to do here is just simplify the fraction. 10 and 8 are both divisible by 2. So 10 divided by 2 is going to get me a 5. 8 divided by 2 is going to get me a 4. And I am completely happy saying that x is equal to 5/4. And here's the deal. With a linear equation, we are looking for one specific value, if it exists, that makes the equation true. And in this case, the one specific value that makes our equation true is when x is equal to 5/4. Okay? Now, how does that differ from an inequality? Well, first of all, this is a conjunction. So this is actually two inequalities. We have 8 is less than 2x minus 4, and 2x minus 4 is less than 14. So let's go ahead and solve this. We're going to do a lot of the same kind of steps here. We want to get x by itself. So I'm going to add 4, but be careful because this is a 3-part inequality. So I'm going to add 4 and add 4. 8 plus 4 makes 12, less than 2x. That's gone. Let's see, 14 and 4 is 18. Yeah, sounds good. And to get x by itself, I'm going to divide by 2. So divide all 3 parts of inequality by 2. So 6 is less than x, which is less than 9. And so when we go to graph this, because here's the thing with the inequality, is I'm going to be looking for 6 to be less than x and x to be less than 9. Right? Those are my 2 parts of my inequality. There isn't one answer to this problem. There's a whole bunch of numbers that make this inequality true. But what we're going to look at are these boundary values, and then where are we going to be doing our shading. So for the first boundary, we're looking for 6. So let's go ahead and put that on a number line. Actually, put both of them on the number line, 6 and 9. So 6 is less than x, which makes x greater than 6. So on my number line, I'll use orange, I guess. I'm going to shade x is greater than 6. And at 6 itself, we're going to use a parentheses. Both these are going to use parentheses. Now they look at it. And then I'll go ahead and grab light blue here. And we want x to be less than 9. So if I shade from 9, that means I got to shade to the left there for less than 9. And at 9, I'm going to use a parentheses there. So here's the thing. With this inequality, this conjunction, the values between 6 and 9, all of these values, and it sounds like, there's not that many of them. There's actually a whole bunch of numbers between here. If you think about all the decimals and the fractions and all the possibilities between 6 and 9, those are all values that make this inequality true. All right. So with an equation, right? An equation, we have one specific value that makes our equation work, okay? With an inequality, we're looking for a whole range of numbers, and so that's why we shade the number line and we do our interval notation, okay? So what we're going to start doing is we're going to start graphing linear equations and linear inequalities. So problem number 3 here, we have a linear equation. Now, you guys have been doing stuff like this. This is nothing more than y equals, that's an mx plus b. So that means we're going to start here, right? This is our y-intercept. So on the y-axis, I'm going to go down to -3. There's my little point. And then I'm going to move using slope. So this is going to be up 1, what would that be? Right 2. So from this point, right, our y-intercept here, we're going to go up 1 to the right 2, make a new little point. And I continue doing this simply because, especially if I'm working on pen and paper or pencil and paper, I want to be as careful as I can to draw a straight and accurate line. And then I'm going to play connect the dots through those points. And that looks fabulous. All right, so this is the one line that makes this equation, right? These are the individual points. All these little points on here that make up this line make that equation true. I keep saying inequality, but it's an equation, okay? Now, what happens if I take this equation and I make it an inequality? So we're going to break this down into a couple of things. So the first thing we're going to do is we're going to draw what's called a boundary line, which you actually just did in the last problem. So your boundary line is to do y equals 1/2 x minus 3. Now, I'm not going to go through the whole steps again. We just did it in the last problem. So -3, right, up 1, right 1, up 1, right 2. I know I was graphing it right, saying it wrong. Okay, now I've got some dotted lines here. And we want to figure out, is our boundary line going to be dotted or dashed? Those are two terms that we use all the time. Or is it a solid boundary line? So for dotted boundary lines, your inequality, this is where the inequality kicks in. Your inequality is going to be greater than or less than. For a solid boundary line, it's greater than or equal to, less than or equal to. So if you have the equal to part, you want to use a solid boundary line. And sure enough, we have a equal to part. So when I graph my boundary line, I am going to make that a nice solid line there. I'm going to twist it up a little bit and then slide it back in place. Sorry. Good enough. Okay. So arrows at the end and end. Okay, cool. So we graph the boundary line. We know it's dotted or solid. We got that part. Now for the shading aspect. Because just like and I'm going to pinch in here so you can see this one. So just like problem number 1 up here, we had some shading, right? Some part of this number line that was all of those values were true. When we graph a linear inequality, 1/2 of this graph is going to get shaded in because all the values on that half will be true statements. Okay, so how do you know which way to shade? So there's a couple of different ways, but one of the easiest ways is to simply figure out if you are going to be shading above your boundary line or if you're going to be shading below your boundary line. So if you're going to shade above the boundary line, so here's your boundary line. If you're going to shade above it, your inequality is going to be greater than or equal to. If you're going to shade from your boundary line and below, you're going to do less than or equal to. So your inequality sign is going to give you a lot of information. It's going to tell you whether you're dotted or solid for your boundary line, and then your shading, if it's greater than, we're shading above. If it is less than, we're shading below. And so for our inequality, we want y to be greater than 1/2 x minus 3, so greater than that boundary line. So that means from my boundary line, I am going to shade above it. All right. So that's how you graph a linear inequality with two variables. I'm going to go ahead and cut the video here. I'm going to make a separate video going into the other couple of questions that are on this note sheet. All right. So let me know if you have any questions or concerns, and I will see you in the next one.